So in this video, we're going to talk about how to use rational equations to solve some real-life problems. So here, it gives us our steps for solving word problems involving rational equations. So you always want to start off with your word problem solving strategies. Remember to always start off by reading the problem carefully by highlighting, circling, or outlining important information. Then you want to identify the variables and determine the equations or formulas you need to solve the problem. And then solve the problem. And remember, what we do generally with rational equations is we want to multiply both sides by the least common denominator. Okay, and then we always want to check for any extraneous solutions. So let's try this first problem. It says Peter rides his bicycle. When he pedals uphill, he averages a speed of 8 miles per hour. And then he pedals downhill, he averages a speed of 14 miles per hour. The total distance he travels is 40 miles, and the total time he rides is 4 hours. How long did he ride at each speed? Okay, so let's think about this problem. So it says how long, so it's asking us for time, right? Well, we need to use this formula here that we use in actually a lot of word problems. So we have this distance equals rate times time, okay? And you probably definitely have seen this before. So we actually need to rearrange this formula so that we have it solved for time, right? Because that's what we're trying to figure out. So if we rewrite this as distance over rate, you see all I did here was divide rate from both sides. We have something that's equal to time. Okay, so the time he spends on this bike ride is actually in two sections, right? We have a part where he's going uphill and a part where he's going downhill. Okay, so let's just write expressions to represent these. So the distance he goes uphill, we don't know, so we're just going to call it D. And then he does that at a speed of 8 miles per hour. Okay, so we have D over 8. When he goes downhill, well, we don't know the distance, but we do know the total distance is 40, right? So if the total distance is 40, this is going to be 40 minus D, and that's over the speed, which is 14 miles per hour, okay? So also another piece of information we have here is that the total time is 4 hours. So that means if I add these two sections together, so if I have D over 8 plus 40 minus D over 14, we have the total time, which is equal to 4, okay? So now, just like any other rational equations problem, we want to find the least common denominator. The least common denominator of 8 and 14 is going to be actually 56. Okay, so I'm just going to multiply every single term in this equation by 56. Okay, so it's going to be 56 times D over 8 plus, and then here 56 times 40 minus D over 14. And then that's equal to 56 times 4. Okay, so on the left side, what's going to happen here? Well, this 56 and 8, that'll reduce, right? So I just have a 7 up here because it's like a 56 over 1. Here, 56 and 14, that reduces, so I just have a 4 up here. And then on the right side, I have 56 times 4, and 56 times 4 is going to give me 224. Okay, so let's go ahead and rewrite that now. So we have 7D plus 4 times 40 minus D is equal to 56 times 4, sorry, which is 224. So I'm going to distribute this 4, and I have 7D plus 4 times 40 is 160. So 160 minus 4D, and that's equal to 224. Okay, so now it's just like a regular algebra equation. I need to combine my like terms. So I have 3D plus 160 is equal to 224. I subtract 160 from both sides, and I have 3D equals 224 minus 160, which is 64. And then I divide both sides by 3, so I have D equals 64 divided by 3, which is 21.3 miles. Okay, so it says 21.3, but you have to be careful what it's asking you for in the problem, right? And what did D represent? So 21.3 miles is going to be how much time how long he went uphill, right? But it's asking us how long did he ride at each speed. So we also need to figure out the length that he went downhill, right? So remember, that was that 40 minus D that we had. So to figure that out, I'm just going to take this value that I have. So I do 40 minus 21.3. And so I just, go ahead and do that on my calculator. And that gives me 18.7. Okay, so that means he went 18.7 miles downhill. So make sure that you answer like both part of the question when you're working on solving these problems. Okay, so here's another example. It says, last weekend, Nadia went canoeing on the river. The current of the river is 3 miles per hour. It took Nadia the same amount of time to travel 12 miles downstream as it did to travel 3 miles upstream. Determine how fast Nadia's canoe would travel in still water. So once again, we have a problem that's kind of like in two parts, right? Because she's going upstream and she's going downstream. So here's some information. We have the same amount of time to travel 12 miles downstream. and then travel 3 miles upstream. Okay, so that distance equals rate times time. We're going to need that again. And once again, since we're talking about time, we're going to say time equals distance over rate. Okay, so let's go ahead and figure this out now. So in still water, if we say that the speed is s, okay, so that's just the canoe in still water. If we say it's s, if it's traveling downstream, okay, if we think about that, you have to kind of think about a canoe when you're solving these problems. So let me just draw this canoe. If you're going downstream, the way the water is flowing is actually going to help you, right? So you're actually going to be going a little bit faster. So what we would say is that when she's going downstream, like the current of the river, that 3 miles per hour is going to help her out. Okay, so we would say s plus 3 is how fast she's going downstream. Okay, because you can think about it. If you've ever been in a canoe or a boat, it's just going to kind of push it downstream. Okay, if she's going upstream, she's actually going to have to go against the current, right? So the current is going to push back at a rate of 3 miles per hour. And so she's going to have to go against that. So that's actually going to be a slower speed because she's kind of having to move her canoe against the river. Okay, so s minus 3 equals upstream. Okay, so now let's think about all the information we have. So we know that downstream, she's going to go s plus 3, right? That's going to be her speed. So that's going to be the rate. And then the distance she goes downstream is 12 miles, right? So we can say downstream, we have 12 miles, and then the rate is going to be s plus 3. And then if we think about upstream, let's just say upstream, she's going to go 3 miles, and then that rate is going to be s minus 3, okay? So actually this problem is interesting because it tells us that she took the same amount of time to go either way, okay? And since these are both representing time, since it's the same amount of time, we can say 12 over s plus 3 is equal to 3 over s minus 3. Okay, and then now we just need to use any of our methods to solve this. I'm actually going to do the crisscross multiply because I think that's easiest when you have just one rational expression on either side. So when we do that, on the left side, we get 3 times s plus 3 is equal to 12 times s minus 3. Okay, so now we just do the regular algebra steps, right? Like distribute. So we have 3s plus 9 equals 12s minus 36. Remember, when you have a variable on both sides, you want to move all the variables to one side of the equation. So I'm going to subtract 12s from both sides. So I have negative 9s plus 9 is equal to negative 36. So that gives me negative 9x equals negative 36 minus 9, which is negative 45. And that's going to give me s equals 5 when you go ahead and solve that equation. So now we want to think about what does s represent, right? S represents actually the speed in still water. That's how we defined it. So we would say 5 miles per hour is the speed of our canoe in still water, and that's exactly what this problem asked us to solve.